All right, Gen Chem host, we are getting more into balancing of redox reactions. And in this video, we're going to look at an example, a tougher example as far as an acid, mediated type of redox process. So we're going to be looking at an example of balancing redox under acidic conditions. So that's specifically what we're going to be looking at in this video, and definitely want to up the ante with the level of question. We did an example in the last video, which was, in terms of these redox expressions, pretty tame. This one I kind of will, I think, open your eyes and show you how complex these can actually get. So let's look at this example. And as we go, we're going to reinforce that methodology that we introduced in the last video. A little bit more shorthand, not as much text here with the actual examples. So if you're looking for that, a more intricate detail, description of this methodology, please look back to the prior videos for that process. So we want to balance the following redox reaction that was conducted under acidic conditions. And our redox reaction looks like this. So there is our redox reaction. We have the sulfurous acid reacting with dichromate to produce sulfur as S8 and chromium +3. And remember that we are under that idea of acidic conditions. So to reinforce our method, the first step was to assign oxidation numbers. And so what we're looking for is what is being reduced, what is being oxidized. So if we go up top here and start to assign our oxidation numbers, if we look at the H2S, the hydrogen would have a +1. There are two of them actually there, so that means that it would have a total of +2 as far as the sum is concerned, which means that the sulfur must be -2. So hydrogen +1 for its oxidation number, sulfur -2. With the dichromate, our oxygens are -2. There are 7 of them, so there's a total of -14 for them. That means our chromium must be, in terms of a total, have +12. And so each chromium atom then has that +6 oxidation number. If we go over to our products, sulfur exists naturally as S8, so it would have a 0 oxidation number, and chromium monoatomic in that +3 charged state, so it would have a +3 oxidation number. So in looking at the changes that are occurring, we see that, the sulfur is going from this -2 oxidation state to a 0 oxidation state. And if we look at the chromium, it is actually going from a +6 oxidation number or state to a +3. So those are the species that are being reduced and oxidized. The sulfur is undergoing the oxidation, while the chromium is undergoing the reduction. So if we look at the chromium is going from the +6 state to the +3 state. So that is a gain of electrons. So that chromium is being reduced. And that means the sulfur is being oxidized. And the sulfur is going from the -2 state to a 0 state. So that's a loss of electrons. So that's the first step. We have to figure out, okay, what are the oxidation numbers? I went through that relatively quickly, so look to prior videos if you're still having trouble with assigning oxidation numbers. It's crucial to the first step and the beginning of balancing these redox processes. So now that we've assigned the oxidation numbers, we can look at the differences or the changes that occur from going to starting materials to products, and that now tells us what is actually being reduced or gaining electrons, the chromium in this case, or what is being oxidized or losing electrons, the sulfur. So step 2 is to develop the half reactions for both the reduction and the oxidation. So for our half reaction for reduction, we are looking at the dichromate going to produce chromium +3. Here we have the chromium in that +6 state. It's going to chromium in the +3 state. Right? This is a reduction gain of electrons. So there's our reduction half reaction. And then we want to do the same thing for now our oxidation half reaction. And so we would look at the sulfur. Going from sulfurous acid to S8. And if we look at the oxidation numbers, we have our -2 going to 0. That's an oxidation. That's a loss of electrons. So those are our two half reactions, our half reaction for reduction and our half reaction for oxidation. Right, remember now we want to do the following steps individual for each of the half reactions. So we're doing each one of these individually as far as the next steps, 2A through 2E. So for step 2A, remember we want to balance elements other than hydrogen and oxygen. So if we look at that reaction, we had the dichromate producing chromium plus 3. So we would want to add a 2 in front of the chromium plus 3 in order for it to be now balanced. With the next step, 2B, now we balance oxygen with the addition of water, or H2O. So if we look at our reaction now, we would have our dichromate producing our 2 chromium ions that are plus 3, but now we're balancing out the oxygen. So there are 7 oxygens on the left with the dichromate. So I need to add 7 H2Os to that product side. So that's the second step. Or part B. 2C, now we balance hydrogen with protons, or with H+. So if we look at our reaction now, again we have the dichromate producing the 2 chromium ions that are plus 3. We have the 7 H2Os. So that would be 14 hydrogens that we have to balance out. And so that is what we're now putting on the starting material side. So we then go to 2D. We can skip 2D because we're not under basic conditions. Right? We're under acidic conditions. And so within 2E, we want to balance charge with electrons. So our reaction at this point looks like this. We have 14 protons plus our dichromate produces 2 of the chromium ions and 7 H2Os. And if we look at our charge idea, we have a total of plus 12 on the left, 14 plus 1 protons, and then the dichromate, which is minus 2, so that gives us a total charge of plus 12. And over here we have a total charge of plus 6. As far as the 2 chromiums, each are plus 3, so that's where the plus 6 comes from, and the water is neutral. There's our reduction, and we can talk about it now being more specific as far as a gain of 6 electrons, right? In order to go from a plus 12 state to a plus 6 state, there must have been 6 electrons accepted, and so that is what we would put on the starting material side, that we have those 6 electrons carrying out that reduction. And now our charges are balanced. So the balanced half reaction for our reduction is going to look basically like what we have there above. So just to summarize, we would have our 6 electrons plus 14 protons plus the dichromate produces 2 chromium ions that are both plus 3 and 7 H2Os or water. And there is our balanced half reaction for reduction. Now we want to do the same steps. As far as 2A through 2E for now other half reaction. So now we're looking at that half reaction for oxidation. And so this was our, just to remind us, this was our half reaction for the oxidation, looking at the sulfurous acid being oxidized to produce S8. So just reinforcing those rules again. So we want to balance elements other than our hydrogen and oxygen. So we would have to, put an 8 in front of our sulfurous acid so that the sulfurs are balanced. Step 2B, we balance oxygen with H2O. Right, in this case, there is, no oxygen. So we go to, the next step, or 2C. And so we want to balance now our hydrogen with protons. And if we look at the top there, we have our 2 or really 16 hydrogens that are there with the sulfurous acid. So we have our 8 sulfurous acids now producing our S8 and 16 protons. So we've balanced out now the protons. Remember 2D we can skip. Right, and we can skip because we are not under basic conditions. So just like we did before. And now we're at step 2E, which is to balance charge with electrons. So if we rewrite our reaction at the top there, we have our sulfurous acid, producing our solid sulfur, and 16 protons. And if we look at our charge, we have a charge equal to 0 on our starting material side. Everything is neutral. If we look at our total charge on the product side so far, we have a charge equal to plus 16. And so that's what we need to then balance with the addition of our 16 electrons. So if we add the 16 electrons to that product side, right, we need that to balance charge. So that means we would have, at the end of the day, as far as our balanced half reaction for oxidation, we would be looking at the sulfurous acid, pretty much what we have above there, producing the solid sulfur, 16 protons, and 16 electrons in that process. And so there is our balanced half reaction for oxidation. So basically, now that both half reactions are balanced, we can now go to step 3 and combine. So step 3, we want to combine the half reactions. Again, making sure electrons, or I should say number of electrons, is the same for reduction and oxidation. So let's write those two reactions again, starting with the reduction side of things. We had our 6 electrons plus our 14 protons plus our dichromate produced our chromium ions, 2 of them, and 7 H2Os. So there's our half reaction for reduction. And then we just did the oxidation half reaction, so that's looking at our sulfurous acid to produce our S8, as well as 16 protons and 16 electrons. So here's where we need to do the cross multiplication step. That we really need to multiply the top by 16 and the bottom by 6. And so that's our cross multiply idea, or multiplication idea, with the actual electrons. We can make it a little bit, more simple, meaning that we could just multiply through by 3 and by 8 and get the same idea as far as the balancing is concerned, since both 16 and 6 are divisible by 2. So we want to do that cross multiplication, and we want to sum up the reaction. And so this is a pretty big reaction, as you can start to see now. So it's going to be somewhat tiered here. So starting with the top, we take 8 times 6, we have 48 electrons. We take the 8 times 16, we get 112 protons. Told you it was going to be complicated. We take the 8 times our dichromate, so we have 8 of those dichromates in that -2 charged state. Those are all the starting materials for the half reaction for reduction, the top one. And now we go to the bottom one. We take our 8 times our 3, and so we would get 24 of those sulfurous acids. And so those are basically now going to produce the following products. So looking at the product side, we have our 8 times our 2 chromium, so we have 16 chromiums that are plus 3. Take our 8 times our 7 H2Os, that means we have 56 H2Os. We now go down to the oxidation half reaction. We have our S8, we're multiplying that through by 3. So there's 3 of the S8s in that solid state. Then there are also, as far as then taking the 3 and multiplying it by the 16, we have plus 48 protons. And 48 electrons. So that is our overall process, and as you can see, it's quite big as far as the actual reaction is concerned. So there's our overall process. And now what we want to do is simplify. In step 4, we want to simplify reaction, right? Removing the redundancies. And so if we go up to our reaction, the first thing we should see is that our electrons should cancel out. We have 48 electrons on the starting material side as well as the product side, so they cancel. We have some other things that cancel out as well. Notice that we have 112 protons and 48 protons. So this would go to 0, and that would go to 64 as far as the protons are concerned. But then that's all the ambiguity or redundancies that we have. So as far as the simplified reaction, we would have 64 protons plus 8 dichromates are 24 sulfurous acids. And those are our starting materials, and that would then be producing our 16 chromiums that are all in the +3 state, our 3 S8s, and our 56 H2Os. This can't be simplified any further, since not everything is divisible by 3. We can do the charge check to make sure that we're still good with our charges. Just kind of a final test of where we're at. And we find that our charge on our starting material side would be equal to plus 48. Or we have, plus 64 from the protons, each one plus 1. And then we would be subtracting off, minus 16 as far as the 8 dichromates, each one being minus 2. And if we look at the product side, we find that the charge is the same. So because of that, we now have our balanced redox reaction, where that would be basically what we have above. I just always like to do that last check to make sure things are working out with the charge and the combination and the simplifications that we've just done. So we have our starting materials, the 64 protons, the 8 dichromates, the 24 sulfurous acids to produce our 16 chromiums that are plus 3, our 3 S8s, and our 56 H2Os. And that is our balanced our balanced overall redox reaction for this particular example under acidic conditions. As you can see, it gets very, very, very complicated. Lots of places to make errors in simple multiplication, balancing, not only with elements, but also with electrons, and then combining it all. So it is very, very tricky. So here, definitely a good example of balancing a redox reaction under acidic conditions. In the next video, we'll be looking at the same process, reinforcing this methodology of balancing redox reactions, but now looking at the other side of the coin, which is what about balancing redox reactions under basic conditions? So look for that next.